Kia ora Year 11. This video is made to help my tutor group getting ready for the MCAT. So I know there are quite a lot of other videos out there already that look at old MCAT questions. I'm going to see if there's any demand for this from people at school, and if there is, then I'll keep making them. And if there's not, then that's cool. I'll just keep on going with my Year 9 and my A-level videos for this year. What I've done in this video is the first 5 questions in the MCAT. So there's quite a big range of difficulty in here. The first question is the only one in question 1 that is just an achieved question. And then there are 3 questions that will help you get towards an excellent. So that's B, D, and E. And C gives you a relational tick. I'm not going to go through the whole mark schedule. I'm just going to do the questions fully in each case. So this first one here, question A, is one where we have to do some substitution. We have to find the value of this expression when x is -3 and when y is equal to 4. So to do that, we want to start off by just writing out the expression. So 2x squared minus 3xy. And then we're going to substitute in -3 for x and 4 for y. And we just have to watch out for our order of operations here. What we've got here is we've got 2 times -3 times -3 minus 3 times -3 times 4. This is the thing to watch out for, especially, is that a negative number squared is going to give us a positive number. So that's going to be 2 times 9 plus 3 times 12, right? Because over here, we've again got a negative times a negative. That gives me 18 plus 36, and that equals 54. Okay, on to the next question. So the next 3 are all examples of quadratic equations. And this one is a straightforward quadratic, except that it doesn't equal 0 yet. And we're told that we've got this equation and it's got 2 solutions, and those 2 solutions are P and Q. And P is the big one. We have to work out the value of the big solution minus the value of the little solution. So when you see a quadratic equation and it doesn't equal 0, the first thing you need to do is to try to make it equal 0. And that's that's just one step of working here. So 6 is equal to 2x squared minus 11x. I'm going to take 6 away from both sides so that I have 0 here. So we have 0 is equal to 2x squared minus 11x minus 6. Now I need to factorize this so that I can find those 2 solutions. And there are a few different ways to do this. One way is just by looking. If you've done lots of practice, you'll see that this has got to be, this 2x squared has to be coming from 2x times x. And then I have to think about, what do I need to put in here? So if you can see that straight away, that's fantastic. You can go ahead and do this question. But I'm going to go through the method that we call grouping to show you how we can work with this. So we've got 2x squared minus 11x minus 6. So I need to find 2 numbers that multiply together to give me 2 times -6. So 2 numbers that times together to give me -12. And those same 2 numbers have to add together to give me -11. What I'm trying to do here is to break up this to make it really easy to factorize. So let's think about numbers that are going to have a gap of 11 and times together to give me 12. So those numbers are going to be something to do with 12 and 1. So let's put 12 and 1 in here now and see which one we want to be the negative number. We want 12 times 1, it has to give me -12, but they have to add to give me -11. So I want to put the negative number in here with the 12, right? And that's how we're going to split this up here. So 2x squared minus 12x plus x minus 6 is what I'm working with. I'm going to factorize the first 2 terms. So we'll get 2x as my common factor here, 2x times x minus 6 here, and now I'm going to factorize these 2. And you can see that I've already got what I want. I've got plus 1 lot of x minus 6. Right, so there's no common factor obviously in there, but I know that it's matching up with this. So hopefully if you're watching this video, this is definitely not going to be the first time that you've seen grouping used. This should just be a bit of revision. So we've got this. So we've gone from up here, where we started off with this thing here. So let's just go through those steps again. So we started with 6 is equal to 2x squared minus 11x, and then we had 0 is equal to 2x squared minus 11x minus 6, and now we've got 0 is equal to this. And the last step is to find those two solutions. So 2x plus 1 is equal to 0, or x minus 6 is equal to 0. That gives me that x is equal to, so 2x is equal to negative 1, x is equal to negative 1/2, or x is equal to 6. And p was my big number, so p is 6, and q is negative 1/2. And that means that I can find p minus q, and that's going to be 6 minus negative 1/2, which is 6.5, or fine to write 6.5. Either of those is good. Right, a couple of questions left to do. What have we got? Oh, where's it gone? Here we go. Okay, another quadratic. Find the values of the numbers m and n that will make this equal to this, given that m and n are both positive numbers, which is going to make life a little bit easier. So on the left-hand side, which I'll write as LHS, we've got 2x plus m squared, and we can expand that out like this. This one times this one, 4x squared, this one times this one, 2mx, this one times this one, 2mx again, plus m squared. Right, and we can collect up our like terms. We get 4x squared plus 4mx plus m squared, and that has to equal 4x squared plus nx plus 9. So if we match these two up, this is what we get. Well, we can subtract the 4x squared off each side, so we get 4mx must equal nx, so 4m has to equal n, and we have the m squared must equal 9, and we're told that both of those numbers are positive, so m is equal to 3, and we can ignore m is equal to negative 3. So if m is equal to 3, then n is equal to 12. So that's that question done. So that's a merit question. All right, what's next? Okay, this next one looks really, really awful, right? But you know that at level 1, you've only learned how to do quadratic equations. So what you've got here is this equation, which is a quartic, right? It's got w to the power of 4. But if we look at what's going on, we can easily change this into a quadratic. And we're going to do it as follows. So we'll start down here with w to the power of 4 minus 18w to the power of 2 plus 81 equals 0. But if we change w into u, and we say let's let u be w squared, well that means that u squared will be w to the power of 4. So this is what we call a disguised quadratic. We've got u squared minus 18u plus 81 is equal to 0. Factorising that suddenly gets really easy. We've got a perfect square, u minus 9 times u minus 9 equals 0, which means that u has to equal 9, but u is w squared, right? Our answer has to be back in terms of w, right? That up here, we are saying, give me the values of w that make that true, not just the values of u. So what can w be? Well, w can be 3, or it can be negative 3. Remember, there are two solutions to w squared equals 9. So that's that question done. All right, the last one is not a quadratic equation. It's a rearranging one. So we're given an expression for r, which depends on y and x. And we have to give the equation for x in terms of y and r. The other way to say what we have to do here is make x the subject. Okay, So let's start off and see what we've got. Well, r is equal to 5y minus 4x over y minus 2x. At the moment, we've got x's here and we've got x's here. We somehow want to separate them out. So we're going to start by multiplying both sides through by the denominator. R times y minus 2x is equal to 5y minus 4x. And if I expand this out, we start to be able to see how we can split out the terms that have got x. Just write that out a bit better. So we'll expand everything. We get r times y minus 2r times x is equal to 5y minus 4x. Next step is just to get all the stuff with x's to one side and all the other stuff to the other side. So it doesn't matter which way you go here, but I'm going to start by just moving this by adding it to both sides, right? So we're going to have ry is equal to 5y minus 4x plus 2rx. And now this has got an x in it, this has got an x in it, but this doesn't. So I want to subtract the 5y from both sides. So ry minus 5y is equal to negative 4x plus 2rx. The next thing I want to do is to say, well, I want to end up with x equals something. On this side, I've now got a common factor of x. I've got x goes into, so x times what will give me negative 4x, negative 4 plus 2r. So we factorize here. And now we can divide both sides through by this. And we get ry minus 5y divided by negative 4 plus 2r is equal to x. Now that doesn't look very nice, but that's a fully correct answer. The nicer way to write that is to say x is equal to ry minus 5y. And here I'm going to reorder that, 2r minus 4. So that's fine. If you're looking in the assessment schedule, you'll see that they've got it all the other way around. And that's fine because we can multiply both numerator and denominator by negative 1. And that will give me 5y minus ry over 4 minus 2r. So that's also correct. And the other thing that I can do here, but I don't have to do, is I can factorize out y, and I can factorize out a 2 and write it like that. Okay, and that's fine as well. I probably would have done this one. You don't have to do that in this case. What you do have to do is make sure that you've got x equals blah, 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 and you've got to have all of your y and your x stuff nowhere near your x's. All right, thanks for watching. If you're in my tutor group and this is helpful, then can you shoot me an email or let me know when you see me next term?